Why does time slow down? Here's what most people believe. They think speed does something to time, like time is a river, and if you move fast enough, the current changes. That belief is not a little wrong, fundamentally wrong. Time doesn't slow down because you're moving fast. Time slows down because light refuses to move faster. Here's a fact that should stop you cold. Right now, GPS satellites orbiting Earth experience time slightly faster than you do. Not metaphorically, literally. Their clocks tick faster by about 38 microseconds every day. Sounds tiny, but without correcting for it, your phone's location would drift by 10 kilometers daily. Your Maps app would be useless by lunch. You've used GPS today. You've relied on time dilation without knowing it. This isn't abstract theory. This is your Tuesday morning commute, and it changes how you understand not just time, but space, speed, and what it means to exist in a universe that keeps strict books. The constant is light. Everything else adjusts. Let me show you. Grab your phone. Seriously, do it right now. Turn on your flashlight. Point it at the wall. Light leaves your phone, hits the wall. Instant. About 1 nanosecond for every foot of distance. You don't see the travel, you see the arrival. Simple. Now here's the thing. What if you started running toward that wall? Full sprint, flashlight still on. Does the light hit the wall faster? Your gut says yes. You're adding your speed to the light's speed. Basic addition. A 5-year-old could figure this out. Wrong. The light hits the wall at exactly the same speed. Whether you're standing still, walking, running, flying in a jet, orbiting Earth at 17,000 miles per hour, same speed, always, every single time. That's not an answer. That's the problem. Hold that thought. Let's make it weirder. Imagine you're in a spaceship, moving at half the speed of light. You turn on your flashlight. You point it forward. How fast does that light move away from you? You'd think, my speed plus light speed, so 1.5 times light speed. Nope, you measure the light. It's moving away from you at exactly light speed, not faster. Now, someone on Earth watches your flashlight beam. They measure it too. Guess what they see? Light speed. Exactly. Both of you measure the same speed, even though you're moving relative to each other at half the speed of light. This is where your intuition fails. People say light behaves like a bullet. Fast, predictable, additive. But that's just a label. Light doesn't add. Light doesn't negotiate. Light doesn't care how fast you're moving. Light moves at 299,592 458 meters per second, period. The universe keeps strict books. And that number, it's the one entry that never changes. So here's the question that should keep you up tonight. If you can't change light's speed by moving toward it or away from it, what does change? Everything else. Your time, your length, your mass. The universe will bend, stretch, and compress anything to keep that one number sacred. Think about what just happened. You pointed a flashlight at a wall, and buried in that simple action is the reason time itself can slow down. Not poetry, not philosophy, accounting. Let's zoom out. You've seen the problem. Light won't speed up, light won't slow down, no matter what you do. So how does the universe keep this number constant? Here's the part nobody tells you. The universe has a budget, a strict budget, and light speed is the total, fixed, unchangeable, written in cosmic ink. But here's the trick. That budget has 2 line items, space and time. You're always moving through both. Right now, sitting there, you're moving through time at maximum speed, through space at almost zero. But start moving through space faster, something has to give. The budget is fixed. The total can't change. So the universe moves money around. You gain speed through space, you lose speed through time. Beautiful. That's not a metaphor. That's the mechanism. Think of it like this. You have $100. That's your total. Always 100. You can spend 100 on time, or 100 on space, or split it 50-50, 70-30, whatever. But you can never spend 101. The constant is enforced. Now watch what this implies. A photon, a particle of light, spends everything on space, all $100. Every cent goes to spatial movement. Nothing left for time. That's why light moves at maximum speed through space. And that's why light experiences 0 time. Wait, read that again. Light experiences 0 time. From a photon's perspective, the moment it's born is the moment it dies. A photon leaving a star 100 million light years away, from the photon's view, it arrives at your eye instantly. No journey, no waiting, No experience of duration. Wild. You and I, we're the opposite. We spend almost all our budget on time. Very little on space. We crawl through space. We race through time. That's why you age. That's why your clock ticks. But an astronaut moving at 90% light speed, she shifted the budget. More spending on space, less on time. Her clock ticks slower. She ages slower. Reality doesn't issue refunds. It just rebalances. So far we've learned light speed is untouchable. It's a cosmic constant. And when anything threatens that constant, the universe doesn't break the rule. It bends time. It warps space. It does whatever it takes to keep the books balanced. This isn't preference. It's accounting. And here's where it gets even stranger. This idea, this rebalancing, it didn't come from a lab. It came from the imagination of a 16-year-old boy daydreaming, asking one stupid question, a question that broke physics. Germany. A 16-year-old kid named Albert is bored in class. Not lazy bored, dangerously bored, the kind of bored that breaks things. He starts daydreaming. What if I could ride a beam of light? Simple question, a child's question, the kind teachers ignore, but Albert doesn't let go. He imagines himself flying alongside a light wave, matching its speed exactly, moving together like two runners side by side. If he could do that, what would the light wave look like? Here's where it gets interesting. A light wave moves. It oscillates up and down, rippling through space. That's what makes it light. But if you're moving with it at the same speed, the wave should look frozen, stationary, just sitting there. A still photograph of a ripple, right? Wrong. James Clerk Maxwell had figured out the equations of light 30 years earlier. Brilliant equations, perfect equations. They described exactly how light behaves. And those equations said something strange. Light cannot stand still, ever. There's no such thing as a stationary light wave. The math doesn't allow it. A frozen light wave isn't light anymore. It's nothing. Now here's the thing. Every physicist knew Maxwell's equations. They used them daily. But when this contradiction appeared, the frozen light wave problem, they shrugged. Must be a small error. We'll fix it later. Not important. Einstein didn't shrug. He was 16. No degree, no lab, no reputation, just a kid with a question that wouldn't leave. And he made a choice. He trusted the equations over his intuition. Brutal. Think about what that means. His gut said, of course you can catch up to light. Everything can be caught. Trains, bullets, sound. The math said, no, light is different. You can never catch it, never match its speed, never see it frozen. Something had to break. Either Maxwell was wrong or human intuition was wrong. Einstein bet against intuition. He said, what if light speed is the same for everyone, always, no matter how fast you're moving? What would the universe have to look like for that to be true? 10 years later, he published the answer. Special relativity. Time slows down. Space contracts. Mass increases. All because one teenager refused to ignore a contradiction. Let me say that again. Everything we know about time dilation, GPS, space travel, particle physics, traces back to a bored kid in Germany imagining himself riding a light beam and being stubborn enough to follow the question. Light doesn't negotiate. Neither did he. Let's prove it. No math, no equations, just a picture in your head. Imagine a clock, not a normal clock, a light clock. Two mirrors, one on top, one on bottom, a single photon bouncing between them, up, down, each bounce is a tick. Simple. Now, this clock is sitting still. The photon travels straight up, straight down, short path, fast ticks. Got it? Good. Now put that clock on a spaceship, moving sideways, fast. Watch what happens. The bottom mirror moves to the right. The photon leaves going up. But by the time it reaches the top mirror has moved. The photon has to travel diagonally. Same thing going down. Diagonal path. Diagonal is longer than straight. Look, the photon now travels a longer distance between each tick. But here's the brutal part. The photon can't speed up. Light speed is fixed, locked, untouchable, longer distance, same speed. What does that equal? More time between ticks. The clock ticks slower, not because something is wrong with the clock. The clock is perfect. The mirrors are perfect. The photon is perfect. Time itself is passing slower on that spaceship. Exactly. This isn't philosophy. This is geometry. A triangle, a diagonal, a constant speed. That's it. The universe keeps strict books. Light speed is the rule. And if your clock moves, the path gets longer and time stretches to compensate. Do this right now. Hold your two hands flat, one above the other. Imagine a ball bouncing between them. Now slide your hands sideways while bouncing. See the diagonal? You just built a light clock. You just saw time dilation. Theory is nice. But does it actually work? Open your phone. Open maps. That blue dot showing your location, that's time dilation. Working right now in your pocket. Here's how GPS works. 24 satellites orbit Earth. Each one carries an atomic clock. Insanely precise. Loses maybe 1 second every 100,000 years. Your phone picks up signals from 4 satellites, measures the tiny time differences, calculates your position. Simple. But here's the thing nobody tells you. Those satellites move at 14,000 kilometers per hour. Fast. And because they're moving fast, their clocks tick slower than yours. Special relativity. The light clock effect. Real. About 7 microseconds slower per day. Wait, there's another effect. Those satellites are higher up, further from Earth's gravity, and gravity also affects time. Clocks in weaker gravity tick faster. That adds 45 microseconds per day. Net result, satellite clocks run 38 microseconds faster than ground clocks. Every single day. Sounds tiny, dangerous. Light travels 300 meters in 1 microsecond. Multiply that by 38. That's over 11 kilometers of error. Per day, your blue dot wouldn't be on your street. It would be in another neighborhood, another town. Useless. So what do? We program the satellites. We tell them, your clock is wrong. Adjust. Slow down by 38 microseconds daily. We correct for time dilation on purpose. Every second, every satellite. The universe doesn't care about your commute. Light doesn't negotiate. Reality doesn't issue refunds. But we learned the rules, and we built around them. Your Maps app is relativity made practical. And here's where it gets even stranger. GPS isn't the most dramatic proof. Not even close. High above your head, right now, cosmic rays are slamming into the atmosphere. These collisions create particles called muons. Muons are unstable. They die fast. Average lifespan, 2.2 microseconds. That's it. Blink and they're gone. Now here's the problem. Muons are born about 15 kilometers up. They travel close to light speed, about 99.9% of it. Do the math. At that speed, in 2.2 microseconds, a muon should travel about 660 meters, then die. They shouldn't reach the ground, not even close. They should vanish 14 kilometers above your head, but they don't. We detect millions of muons at ground level, every minute, every day, right where you're sitting, quiet. How? Time dilation. From our perspective, the muon's clock runs slow, extremely slow. Its 2.2 microseconds stretches into 50 microseconds, enough time to travel 15 kilometers, enough time to reach us. The muon thinks it lived 2.2 microseconds. We watched it live much longer. Both are true. Wild. But hold that thought. Here's the stranger part. From the muon's perspective, it did only live 2.2 microseconds. Its clock ran normal. So how did it reach the ground? Length contraction. From the muon's view, the distance to Earth shrank. 15 kilometers compressed into 600 meters. It only needed to travel a short distance. Same result, different explanation. Both correct. This isn't preference, it's accounting. The universe keeps both books balanced. Time stretches, or space shrinks. Depends on who's watching. But light speed, same, always. These particles are raining through you right now. Proof of time dilation, hitting your body, passing through, gone. You're swimming in evidence. So far we've learned light speed is constant, time bends, space warps, GPS works, moons survive, but we're still missing the point. Here's the part that changes everything. Time doesn't slow down. Let me say that again. Time doesn't slow down. People say time dilation means time goes slower, but that's just a label. That's the wrong picture. Here's the real picture. You're not traveling through space. You're traveling through space-time. One thing, fused together, inseparable. And you're always traveling at exactly the same speed. Always. Light speed. Exactly. Right now, sitting still, you're moving through space-time at 299,792, 458 meters per second. Not through space, through space-time. When you sit still, all that speed goes into time. You rocket through time, you age fast. When you move through space, you steal from time. Less speed through time. You age slower, but your total speed, unchanged, fixed, light speed. You're always moving at light speed. The only question is, how much goes to space? How much goes to time? That's the deep truth. You don't have a speed limit. You have a speed, one speed, the only speed. Everything travels at light speed. Everything, always. The universe has one rule, one speed, one constant. Light doesn't move at light speed because it's special. You move at light speed too. Light just spends it all on space. You spend most of yours on time. Same budget, different allocation. This isn't physics. This is poetry written in mathematics. Brutal, beautiful, true. So, why does time slow down? Wrong question. Time doesn't slow down. You just redirect where your speed goes. Light taught us this. A 16-year-old boy listened. The universe confirmed it. GPS uses it. Moons prove it. And you experience it every second. You're moving at light speed right now. You always have been. Done. But here's what keeps me up at night. If the universe bends time and space just to protect one number, light speed, what else is it hiding? What other rules are written so deep we haven't found them yet? What other constants does reality protect at all costs? Do this tonight. Turn off the lights. Turn on your phone flashlight. Watch the light hit the wall. Instant, untouchable, constant. That beam is the universe showing you its one true law. Everything else is negotiable. Time, space, your aging, your heartbeat, all flexible. Light, never. The universe keeps strict books. Now you know which entry it will never change, and you'll never see a flashlight the same way again.